There we go. Okay.
In this lesson, we'll be solving linear systems by graphing. Our goal today is to be able to look at a graph of a linear system and determine 1, the number of solutions, 2, whether the slopes are the same or different, and 3, whether the y-intercepts are the same or different. There are 3 possible solutions to a linear system. The first one is when the lines intersect only at one point. The second possibility is when the lines are parallel. They do not intersect. And the third possibility is when one line is graphed on the top of the other line, so you only have one line on the graph. First, intersecting lines. Intersecting lines have different slopes. They have a solution, which is just one point, and they are called consistent and independent. So here we have an example of intersecting lines. They intersect at one point. Now we're going to show you by having an equation that's in standard form and transforming it into slope-intercept form, just to show you what we mean by different slopes. Standard form is ax plus by equals c. So my equation is 3x minus 3y equals negative 6. First thing I do is add 3x to both sides. So you can see that I have now negative 3y equals 3x minus 6. Now to get y by itself, I will simply divide everything by negative 3. So my final equation in slope-intercept form is y equals negative x plus 2. My other equation is 7x plus 4y equals 20. So the first thing I did was, again, move the x to the other side of the equal sign by subtracting 7x. Now I have 4y equals negative 7x plus 20. My last step is to divide everything by 4. Final equation, y equals negative 7 over 4x plus 5. So in this equation, this example, you can see that the slopes are different. No, they do not match the graph example I have up there, but you can see that they were different, and so therefore these two lines will intersect. The next possibility is parallel lines. Parallel lines are when the two lines do not touch. They do not intersect. The important points about parallel lines is that they have the same slope, they have different y-intercepts, there is no solution, and they are said to be inconsistent. The example is, again, in standard form, ax plus by equals c, we have 2x minus y equals negative 12. We move the 2x to the other side of the equal sign by subtracting 2x. Now we have negative y equals negative 2x minus 12. Y still has to be adjusted, and we have to divide by negative 1 on both sides. So the slope-intercept form here is y equals 2x plus 12. My other equation is negative 6x plus 3y equals 8. So I add 6x to both sides, and now I have 3y equals 6x plus 8. Final step is divide both sides by 3. And so in slope-intercept form, this equation is y equals 2x plus 8 over 3, or in mixed number form, 2 2/3. So we can see that we have the same slope on both of these equations and different y-intercepts. They will never intersect. The last possibility, when we have the same line. You can see that there's a little bit of green and black, so that's showing you that this is two different equations, but the same line. So basically, they're not different equations. So in standard form, I have negative 5x plus 2y equals 12. I added 5x to both sides. Now I have 2y equals 5x plus 12. Then I divide everything by 2 to get y by itself. And the final equation in slope-intercept form is y equals 5 over 2x plus 6. The other equation was 10x minus 4y equals negative 24. I subtract 10x from both sides. Now I have negative 4y equals negative 10x minus 24. Final step is divide everything by negative 4